What if I told you that one of the most frustrating diesel engine problems can sometimes be caused by a component that looks almost impossible to clean? A dirty EGR valve can turn a smooth-running engine into a sluggish, smoky, rough-running machine. You may notice hesitation when accelerating, poor throttle response, reduced fuel economy, excessive smoke, or even a check engine light. And when that happens, many drivers immediately assume the EGR valve needs to be replaced. But before spending hundreds of dollars on a new valve, there's a cleaning method that mechanics in Japan have long favored because it focuses on one simple principle: remove the carbon without damaging the delicate parts around it. It isn't a magic chemical, and it isn't about attacking the valve with the strongest solvent you can find. Number 8. Why EGR valves get so dirty. Before touching the EGR valve, you need to understand why it becomes dirty in the first place. EGR stands for exhaust gas recirculation, and its job is to send a controlled amount of exhaust gas back into the engine under specific operating conditions. That sounds strange at first because exhaust gas is something we normally want leaving the engine, not coming back into it. But the system exists primarily to reduce combustion temperatures and help control nitrogen oxide emissions. The problem is that exhaust gas isn't perfectly clean. It contains soot, carbon particles, oil vapor, and other deposits. When these materials repeatedly pass through the EGR system, they can gradually form a thick, sticky layer of carbon. On diesel engines, especially those that spend a lot of time idling or making short trips, the buildup can become significant. Oil vapor from the crankcase ventilation system can mix with soot in the intake and create a thick black sludge that is much harder to remove than dry dust. Eventually, the valve may become restricted, stick partially open, or fail to move through its intended range. That's when symptoms begin to appear. You might feel the engine hesitate under acceleration, experience unstable idle, notice reduced power, or see warning lights on the dashboard. But here's where many people make their first mistake. They assume every EGR-related symptom means the EGR valve itself is bad. That's not necessarily true. A fault code can sometimes be caused by restricted passages, wiring problems, vacuum leaks, a position sensor issue, or another component in the emission system. That's why diagnosis should come before cleaning. If your vehicle has a check engine light, scan the system and understand the code before removing anything. If the valve is electronically controlled, inspect the connector and wiring. If it uses a vacuum actuator, check the vacuum system according to the manufacturer's procedure. Cleaning a perfectly functional valve won't fix an electrical fault. Likewise, installing a new valve won't solve a completely blocked EGR passage. This is why the Japanese-style approach is less about a secret product and more about disciplined maintenance. Instead of immediately replacing expensive parts, you inspect the system, locate the actual restriction, and clean only what can safely be cleaned. And remember, carbon buildup isn't always a sign that the engine is failing. It could be the predictable result of mileage, driving conditions, engine design, and maintenance history. The important question isn't simply, is there carbon? There almost always will be. The question is whether the buildup is enough to interfere with valve movement or airflow. That's the difference between normal contamination and a genuine EGR problem. Number 7. What you need before starting. Now let's talk about preparation, because this is where a safe EGR cleaning job really begins. You don't need a garage full of expensive equipment, but you do need the right basic tools and, more importantly, the correct information for your specific vehicle. Start with the factory service information if you can access it. EGR systems vary dramatically between engines, and a procedure that's safe for one vehicle may be completely wrong for another. Some EGR valves are simple mechanical units. Others are electronically controlled assemblies with motors and sensors attached. Some can be removed easily from the top of the engine, while others are buried behind intake components. Before removing bolts, take photos of the original routing of hoses, wiring connectors, brackets, and clamps. This sounds unnecessary until you're halfway through reassembly and realize you can't remember exactly where a vacuum line was connected. You'll typically want basic hand tools appropriate for the vehicle, a suitable brush for carbon removal, clean shop towels, appropriate eye protection, gloves, and an EGR or intake safe cleaning product compatible with the component you're cleaning. The important word here is compatible. Don't assume that because a chemical removes carbon effectively, it is automatically safe for every material. Strong solvents can damage seals, plastics, coatings, electrical components, and sensor assemblies. If the EGR valve has an electronic actuator attached, don't soak the entire unit unless the manufacturer specifically says that it is safe. In many cases, the safest method is to keep the actuator and electrical section completely dry while cleaning only the metal valve and passage areas. You'll also want a container or tray for removed components, because EGR assemblies often use gaskets, O-rings, clips, or small hardware that can easily disappear into a dirty workbench. Another important preparation step is engine temperature. Never begin dismantling a hot EGR system. Exhaust components can remain extremely hot long after the engine has been switched off. Allow the engine to cool completely, and follow the vehicle's recommended safety procedure before working around the intake and exhaust systems. If you're working on a modern vehicle, you should also understand whether disconnecting the battery affects electronic settings or requires a specific procedure. And before you begin, decide what you're actually trying to accomplish. Are you cleaning the valve itself, the EGR pipe, the intake manifold passage, or the entire EGR circuit? Those are different jobs. The safest approach is to start with the smallest area necessary to solve the confirmed problem rather than dismantling half the engine unnecessarily. Good cleaning isn't about how much you remove. It's about removing the right contamination from the right location without damaging anything that was working properly. Number 6. Removing the EGR valve carefully. Signs of oil contamination. Also check for physical damage. A valve covered in carbon but mechanically sound may be a good candidate for cleaning. Number 5. The Japanese cleaning technique. Now we get to the heart of the method. The so-called Japanese trick isn't about one secret chemical or some mysterious workshop formula. The technique is based on a simple philosophy. Soften the carbon first, remove it gradually, and protect every sensitive component. Once the valve is removed and you've confirmed that the metal portion can be cleaned, place it on a stable work surface. If there's an electronic actuator or sensor attached, keep that portion completely protected from liquid and debris. Start by removing loose carbon with a dry brush or suitable hand tool. Don't immediately attack the deposits with a screwdriver or sharp metal object. The goal is to avoid scratching sealing surfaces or damaging the valve seat. For stubborn buildup, apply a cleaner specifically intended for EGR or intake carbon and safe for the materials involved. Allow the product to work according to its instructions. This waiting period is one of the biggest differences between careful cleaning and aggressive cleaning. Instead of fighting hardened carbon with force, you're giving the cleaner time to soften the deposits. After that, use a suitable brush to work the carbon away gradually. You may need several cycles. Apply cleaner, wait, brush, wipe, inspect, and repeat. Don't rush, because the first layer of carbon can be much harder than the material underneath. As the buildup begins to break apart, use clean towels to remove the loosened residue instead of pushing it deeper into the passage. If you're cleaning an EGR passage, be especially careful about where the loosened carbon goes. You don't want large chunks falling into the intake system where they could create another restriction. Never use compressed air carelessly to blast carbon through an assembled engine system. If you need compressed air for drying, use it only in a controlled way and follow the manufacturer's safety recommendations. Another important rule is to avoid forcing an electronic EGR valve through its travel. If the valve mechanism is electrically driven, don't treat it like a simple metal butterfly. The actuator and position sensor can be damaged by excessive force. The safest cleaning technique is therefore surprisingly boring. Protect the electronics, soften the deposits, brush gently, wipe frequently, inspect repeatedly, and stop when the carbon that matters has been removed. You don't necessarily need the component to look like it just came out of a factory. What matters is that the valve can operate correctly and the intended gas passage is sufficiently clear. This is also why aggressive sandblasting or grinding isn't a good shortcut. Removing material isn't the same thing as removing contamination. You can easily damage a precision sealing surface while trying to make a component look spotless. Clean for function, not appearance. Number 4. Cleaning the EGR passage and intake area. Cleaning the valve itself is only part of the job. In many engines, the larger problem is the carbon buildup surrounding the valve. Imagine cleaning a door perfectly while leaving a pile of dirt packed inside the doorway. The door may move, but the opening is still restricted. The same thing can happen with an EGR system. Carbon can accumulate inside the EGR pipe, mounting port, intake passage, and sometimes deeper inside the intake manifold. If you remove the valve and discover a thick ring of carbon around the opening, don't automatically assume the valve was the only problem. Inspect the passage carefully. If the service procedure allows cleaning that area, remove loose deposits using an appropriate brush and vacuum or collection method designed to prevent debris from entering places where it shouldn't. This is another point where restraint is important. You don't want to break off a large chunk of carbon and allow it to travel into the engine. If the intake manifold is heavily restricted, that may require a separate removal and cleaning procedure rather than try and solve everything through the EGR opening. The safest approach is to follow the vehicle's specific service instructions. For surface deposits that are accessible, use an appropriate cleaner and gradually work the material loose. Avoid scraping aggressively against soft aluminum surfaces. Deep scratches can create sealing problems and can also make future carbon accumulation more difficult to manage. Pay particular attention to the valve seat and the transition between the EGR passage and intake. These areas can develop a narrow opening caused by layers of carbon that aren't always obvious from a quick visual inspection. Once deposits are loosened, remove them carefully rather than blowing them deeper into the system. If you use a vacuum, make sure it is appropriate for the material and cleaner involved and that you're not creating a hazardous mixture. Ventilation is also important because carbon cleaning chemicals can produce unpleasant or harmful vapors. Work in a well-ventilated area and follow the product's safety instructions. And here's another common mistake: assuming that more cleaner means better cleaning. It doesn't. Excessive chemical use can damage materials, create unnecessary fumes, and make cleanup harder. Use enough to soften the deposits and no more. Once the accessible passage is clean, inspect it with a light. You're looking for a clear, reasonably open pathway rather than a mirror finish. If the passage is deeply restricted beyond what you can safely reach, stop. That's the point where removing additional components may be necessary. A professional repair is better than forcing tools into an area you can't properly see. Remember, the objective isn't to prove that you can remove every molecule of carbon. The objective is to restore the airflow path safely and reliably. Number 3, what you should never do. There are several cleaning shortcuts that look impressive on camera but can create expensive problems in the real world. The first is soaking an entire electronically controlled EGR assembly in solvent. Unless the manufacturer specifically approves that procedure, don't do it. Electronic actuators and sensors can contain components that are not designed to be submerged. The second mistake is forcing the valve open with excessive mechanical pressure. If the mechanism isn't designed for manual movement, you can damage the actuator or internal gearing. The third mistake is using extremely aggressive tools to scrape carbon from precision sealing surfaces. A screwdriver may remove carbon quickly, but it can also gouge the metal underneath. Once a sealing surface is damaged, a new gasket may not be enough to stop a leak. Another dangerous shortcut is spraying cleaner into an assembled engine without knowing where the liquid and loosened carbon will go. Products marketed for intake or EGR cleaning are not automatically safe for every engine design. Some vehicles require very specific procedures because of turbochargers, sensors, throttle bodies, diesel particulate filters, or other emissions components. Then there's the common belief that you should make the valve completely shiny. That's not necessary. A functional EGR valve with minor staining is perfectly normal. Chasing a polished appearance can tempt you into removing material that should remain there. You should also avoid using an unknown homemade chemical mixture. The internet is full of recipes involving household cleaners, fuels, solvents, and other substances that may appear to dissolve carbon but can create toxic fumes, damage components, or present fire risks. There's nothing particularly clever about turning a maintenance job into a chemistry experiment. The safer philosophy is simple. Use a product intended for the application, follow its instructions, and keep incompatible chemicals away from each other. Another mistake is cleaning the EGR valve while ignoring the cause of excessive contamination. If the engine has an underlying issue causing abnormal soot or oil accumulation, the valve can become dirty again quickly. Depending on the vehicle, possible contributing factors could include driving conditions, excessive idling, poor maintenance, intake contamination, or another engine or emission system fault. Cleaning removes the symptom, but diagnosis addresses the cause. Finally, don't assume a successful cleaning means the vehicle is automatically repaired. After reinstallation, the system may require an electronic relearn, adaptation procedure, fault code clearing, or a specific drive cycle. Some vehicles monitor EGR position electronically and can detect whether the valve is behaving correctly. If you skip the required procedure, the warning light may remain even though the valve is physically clean. That's why safe EGR maintenance isn't about one trick. It's about knowing what the component does, cleaning it without damaging it, reinstalling it correctly, and verifying that the entire system works afterward. Number 2. Reassembly and testing. After the carbon has been removed and the components are completely clean and dry according to the manufacturer's requirements, it's time to put everything back together. This stage deserves just as much attention as the cleaning itself. Before installation, compare the clean component with your original photos and confirm that every connector, hose, bracket, and mounting point is accounted for. Inspect the gasket surfaces carefully and install the correct gasket or seal specified for the vehicle. Don't assume an old gasket will seal properly simply because it looks acceptable. Exhaust and EGR systems experience repeated heat cycles, and a small leak can create performance problems or allow exhaust gases to escape where they shouldn't. Tighten fasteners using the manufacturer's specified sequence and torque values whenever available. This is especially important when dealing with aluminum components, because over-tightening can damage threads while under-tightening can allow leaks or vibration. Reconnect electrical connectors until their locking mechanisms are properly secured. For vacuum-operated systems, verify that each hose is routed correctly and firmly attached. Once everything is assembled, perform the manufacturer's recommended checks before starting the engine. If a component requires a relearn or calibration procedure, complete it using the appropriate diagnostic equipment or procedure. When the engine starts, don't immediately rev it aggressively. Let it stabilize and listen carefully for unusual noises, hissing, exhaust leaks, or unstable operation. Check the area around the EGR assembly for signs of leakage. If the vehicle has a scan tool, monitor relevant data where possible. Depending on the system, you may be able to observe EGR commanded position and actual position, airflow readings, or other parameters. The exact values vary by engine, so don't rely on generic internet numbers. What you're looking for is behavior consistent with the manufacturer's specifications. After the initial inspection, a road test may be appropriate if the vehicle is safe to drive and no warning signs are present. Pay attention to throttle response, acceleration, idle quality, smoke, and warning lights. Don't expect every engine to feel dramatically different after cleaning. If the EGR was only mildly contaminated, the improvement may be subtle. But if the valve was heavily restricted, you may notice smoother operation and better response. If the check engine light returns, don't simply clear it and continue driving. Scan the vehicle again and investigate the new or remaining fault. A recurring EGR code can indicate a deeper problem that cleaning cannot solve. This is also the point where you should verify whether any service interval or maintenance recommendation applies to the system. The best result isn't simply an engine that starts after reassembly. The best result is an engine whose EGR system is operating correctly and whose underlying problem has been properly identified. That's what separates a real repair from a temporary cleanup. Number 1. How to keep the EGR cleaner longer. Cleaning the EGR valve can restore function, but if the conditions that created the carbon buildup remain unchanged, the deposits will eventually return. That's why the final part of this process is prevention. You can't completely eliminate EGR contamination because the system is designed to handle exhaust gases, but you can pay attention to the factors that influence how quickly deposits accumulate. Driving patterns matter. Vehicles that spend most of their time making very short trips or sitting at idle may experience different levels of deposit formation than vehicles that regularly reach full operating temperature and spend time under normal load. This doesn't mean you should drive aggressively just to clean the EGR. That's an oversimplification. Instead, follow the vehicle manufacturer's maintenance and driving recommendations. Keep the engine properly serviced, use the correct oil specification, and replace air and fuel filters according to the recommended schedule. If the engine has excessive oil entering the intake system, that issue deserves attention because oil vapor can contribute to sticky deposits when it mixes with soot. Likewise, if the vehicle frequently regenerates its diesel particulate filter or has other emission system warnings, don't ignore them. Modern emission systems are interconnected, and a problem in one area can affect another. Another important habit is responding to warning signs early. A slight hesitation today can become a much larger drivability problem later. If you notice a new engine warning light, unusual smoke, reduced power, or changes in fuel economy, diagnose the problem instead of repeatedly treating the symptom. And don't fall into the trap of using an aggressive EGR cleaner every few weeks without understanding whether your vehicle actually needs it. More chemical isn't automatically better maintenance. Preventive maintenance should be based on the engine design, operating conditions, and manufacturer guidance. If your vehicle has a removable EGR valve, periodic inspection may make sense in high contamination applications. But the exact interval should come from reliable service information rather than a universal number. Also remember that EGR cleaning isn't a substitute for proper engine maintenance. A clean EGR valve cannot compensate for worn components, incorrect fueling, sensor problems, intake leaks, or other mechanical faults. The biggest lesson from this entire process is that the Japanese approach isn't really a secret trick at all. It's a mindset. Inspect carefully, clean deliberately, use the least aggressive method that works, and verify the result. That's why it can be so effective. You're not fighting the engine. You're working with the design instead of against it. And when you combine that careful cleaning approach with proper maintenance and diagnosis, you can often extend the useful life of an EGR system and avoid replacing expensive parts unnecessarily.